Alright guys, we're going to do number 21. An object moves with a uniform acceleration and has an initial velocity or has a velocity in the positive vector when its x is 3 centimeters. If x is if its x coordinate 2 seconds later is negative 5 centimeters, what is an acceleration? I encourage you guys to pause this video to get this problem a shot. Presuming you pause this video and get this problem a shot. So this is going to be, it's a little hard to draw this, but so I'm going to say that this is going to be, 0, 3 centimeters here. And at this point, I'm going to call that at when t equals 0 seconds. So at t equals 0 seconds, that's when it is at this point. And its velocity is going to be at 12 centimeters per second. 2 seconds later, so 2 seconds, so at 2 seconds, then its velocity is going to be at, its position is going to be 5 centimeters. I always say the wrong things. Forgive me for that, folks. I can't speak for shit, to be honest. And I know that. If x coordinate at 2 seconds later is at 5 centimeters, what is its acceleration? Okay, wait, let me think about this. We don't know what the final velocity is, but it does give it the acceleration. Uniform acceleration has a, well, we do know this. We know that the direction of the velocity, of the final velocity, has to be in some positive direction. Because if initially it's at 12 centimeters per second, when t equals 0 at this point, and at 2 seconds, it might go a little further, and then it's going to come back down, back to at negative 5 centimeters. That's going to be its new position. What is its acceleration? Well, we do know the formula. And the formula is going to be this. The final position is going to be the initial position plus the initial velocity times the t plus, or you could put a minus depending how you want to label your magnitude, at squared over 2. So I'm going to use this formula. We know what the initial velocity is. It's 12 centimeters per second. We know the acceleration. We don't know what the value of acceleration. In fact, that's what they're asking for. But we do know its final position and initial position. And we do know the time it takes. So the only variable unknown is the acceleration. So all we have to do is take the final position minus the initial position minus v naught t, whatever that is. Multiply this whole thing by 2, divided by t squared, and bam, that's your acceleration. So I'm going to plug all those values in there. So 2 times the position here. And notice that this is going to be speed times the time, so that's just going to be a position. So I'm just going to take the unit and put centimeters on the outside. And the final position is going to be negative 5 centimeters, negative 5 minus the 3. Minus its initial position, minus 12 times 2 seconds, which is going to be 24, all over 2 squared, which in this case, that would be a second square. So this would be negative 8, negative 32. Negative 32 divided by 2 would be, well, the answer is. So once you solve this, the acceleration is negative 16 centimeters per second square. And I hope this is pretty straightforward for you guys. I know this is more of a mathematics that I'm kind of skimming over, because to be honest, I do suck at teaching. However, this is the algebra rules that you guys have to be very familiar, especially when you're at this level. So I hope this helps you guys. Enjoy.